ANSYS Simulation Lecture 11 Part 2 Reaction Surface Optimization. First of all, we drag static structure analysis onto geometry and perform the static structure analysis as before. And in the geometry, we have defined that this is the width of the beam, and the parameter is ds to transfer this dimension to ANSYS. And this is the height of the beam. The height of the beam will be 50. The height of the beam has also a ds key to transfer this dimension as parameter to ANSYS, and the hole diameter is d, the 20 millimeter diameter. So we are in ANSYS. First of all, we can update geometry from SolidWorks, and we have 3 parameters already here. But before we do the optimization process, we perform the original static structure analysis first. So the geometry, the materials, static structure steel, the mesh, will update the mesh. This is the step 3. Step 4, constraints and loading. Surface of the load, direction of the load, magnitude of the load, and we need total deformation and von Mises equivalent stress and run. And this is the static structure analysis as before, but this is really not what we really need. So first of all, we define the design parameters as parameter. So the width of the beam, the height of the beam, and the diameter of the hole are 3 design parameters. And constraints, the maximum of total deformation and the maximum of von Mises equivalent stress. These 2 parameters are for constraints. And the goal, the volume of the beam. So we have 6 parameters. 3 of them are design parameters, and 2 of them are constraints, and the last one is the goal. And then we go back to ANSYS schematic, and then we will drag the response surface to parameter set and edit the procedure. First of all, we will take the default, the width of the beam from 45 to 55, the height of the beam 45 to 55, the diameter of the hole from 10 to 30, and then there is the total deformation equivalent stress. So we update the case, and it will take quite a while, so we will stop recording right now. The solution is about to finish. Okay, the solution is finished. So we can go back to project and enter the response surface, and we update the case. And this won't take long, so we'll wait. And this is the result. For the response surface, there are 2D surface and 3D surface. We choose 3D surface. And then for the x-axis, we can choose, for example, the height of the beam. And the y-axis, we can choose, for example, the diameter of the hole. And the z-axis can be equivalent stress. And we can see a response surface here. And the response surface is most powerful in those cases where there are multiple minima or maxima. For example, in injection molding, there are, for example, 8 parameters, and there can be more than one minima or maxima. So you can see from the response surface where is the local minima and where is the global minima. So we have finished with this, and we'll go back to project and then run the response surface optimization based on the response surface. So we enter optimization setup, and then for the diameter we also have the range of 10 to 30, and the width of the beam from 45 to 55, and H is 45 to 55. And then we'll define constraint. The total deformation, we will seek target, and the target will be lower than the upper bound, and the upper bound will be 0.5 millimeter. So this is the first constraint. The second constraint will be the stress. We also seek target. The target also lower than the upper bound, and the upper bound will be 6 MPa. And for the goal is the volume of the beam. We will seek minimum. So we can go ahead and update the case. And then we get the result. We can see the samples here. For example, for the deflection of 0.5 millimeter and stress of 6 MPa, we have a minimum volume where the width of the beam will be 55, and the height of the beam will be 54, and the diameter of the beam will be 24. And this is the minimum volume case. So you can see from the result that for the minimum volume, the P1 will be 46.6, P2 will be 50, P3 will be 30. So the solution will be a width of the beam 46.6, the height of the beam will be 50.2, and the diameter of the hole will be 29.8. So this is the solution for the multi-design parameter problem. And also, in addition to this optimization, we can also get the response surface. So we can visualize the response surface and also get the optimization result. So this is the response surface and optimization procedure.